Raz, raz, dwa, trzy. Raz, dwa, trzy.
Przepraszam, na jaki adres wysłać prezentację?
Robert.
Thank you very much for joining. I hope that I'm heard well. There is some echo, I think. Is that okay? Yeah, maybe of the... We can start. Yeah? Thank you for joining us for the REUNICE final dissemination event. And today we will have a lot of nice and interesting lectures. It's the final and closing event of our SWAFS project. And we are welcoming our partners, the representatives of our partners. And I would like to ask for the opening. I would like to ask Professor Mariusz Głąbowski, the Vice Rector for International Relations, to open the event.
Thank you very much. It's a real pleasure to welcome you all to today's conference, where we are going to disseminate, to discuss outcomes of our REUNICE project. So I'm really thankful to all of you for coming to Poznan University of Technology, to discuss our approach, how we are going to use science with and for society. The REUNICE project is a great example of our teamwork within the Eunice Alliance. Through this collaboration, we started with 7 universities, then expanded to 10, all working closely with society, with our stakeholders, to address some selected important challenges that affect us all. I'm confident that we achieved great results, some selected great results, and that our work will have a lasting impact. But first of all, I'm confident that we'll continue on to build on solutions that we created in REUNICE to prepare better solutions for our future needs, more customized, according to the name of our university, more customized to our needs. So once again, welcome to our university, and to what promises to be a great day of discussions. I hope that the weather will be also supporting us today. So we are waiting for great gold autumn weather here in Poznan. Thank you very much.
Thank you, Rector, for opening the meeting, and I would like to invite for the opening welcome word the leader of the project, Professor Paweł Śniatała.
Welcome, everybody. So some of you knows already me. So Marta told me that, but be concise, don't talk too much, which is almost impossible in my case. But welcome everybody, especially people who are here first time at PUT. So a few words. As you know, REUNICE was a project which is Horizon 2020, and the issue was that from one side it is a typical scientific project. So we had to prepare a real application with a real results at the end of the project. On the other hand, it was a close call only for the European university members. So it was a little bit easier to get the grants, but still the application and the grant as a whole should make sense. And we did it. Thank you for all of you who support, who give some input to the results. And finally today we are able to successfully finish the grant. As far as I remember, at the beginning, Marta was the person who took care about all of those administration organization issues related to the project, and next Michał Weissenberg took over. And one more thing about Eunice and REUNICE. Oh, about REUNICE, one more thing. You will see, Michał, you will tell about those systems. And the systems is about, we promise that we will prepare some tools to connect people, especially in the topic of AI and some others. And Michał will present you 3 tools, if I remember. But the successful implementation of the tools depends on us. I mean, on people who will input some data inside. Well, we'll see how it will work. But the main goal, I think, that we achieved, which is started to successful cooperation, international cooperation. And the last word about this international cooperation is that I used to, well, it's not a joke, it's anecdote because it's funny, but it's a true story. I used to tell, especially to my colleagues in the US, that speaking with me or anyone from you, anyone from Eunice, you are talking or you are speaking with the whole Europe, because in fact we have now 10 members across the Europe. And when I said to colleague in the US that, you know, our Eunice, our university has 155,000 students, so they were really impressed. Wow, so it's really a big institution. So my point is that, yes, I'm finishing. You know that, you know, few more minutes. So the point is that it works. And today, thanks to the Eunice, thanks to that I was able to use this argument, we got another grant, which is grant together funded with the National Science Foundation in US and NAVA. It is ImpressU. My point is that we have several, but hopefully we will have more examples how Eunice helps also your institution, our institution, because I have one slide when I put information how many grants, in total how many euros, even also dollars, we got thanks to be part of the Eunice. And even on here in this room I see several people, including Dr. Isabella, that we got a really quite big amount of money thanks to be part of Eunice. Thank you very much. And one more thing, I know that the meeting will be very interesting, but at some point I have to go to another room, which is the meeting of ImpressU in parallel. But we will meet during the coffee break and lunch, so we can also chat with the people from the US. We have the guests, as I mentioned, from San Diego State University. And also we have a guest, he will be later a little bit, from National Taiwan University Science and Technology, Professor Poki Chen. His specialization is microelectronics, so it's another possibility to create a networking. Hello. Thank you.
Thank you very much, and it's a good opportunity to have a lot of networking. And I would like to invite to the scene Dr. Marek Zmuda from Intel company to give us some insights on cooperation with academic communities and between the industry stakeholders.
Thank you very much. Appreciate the invitation from the University Directional Board. It looks like the font is completely different that I planned. So I'm also surprised, like you, but let's skip it. Okay, so my name is Marek Zmuda. I'm a system security architect working for Intel. We've got the R&D in Gdańsk, but my second hat is coordination of all cooperation with the universities in Poland. So Poznan University of Technology is the main one that we are cooperating with. So what is our journey? How Intel showed up in Poland? It's somehow related also to the universities. So in 1989, the Polish engineer from the US, Tad Witkowicz, came to Poland. He was working on many companies in the US as an engineer, and he said, "Oh, I've got some money, right? I could invest in Poland in engineers. So what can I do? We've got really well-skilled engineers in Poland. So let's do something, right?" And he came to the Politechnika Gdańska, Gdańsk University of Technology. He found 5 very motivated guys who wanted to do the startup, but they didn't get an idea what they can do and no funding. So Tad Witkowicz talked to them, and they opened the Polish side of the Crosscom. That was networking company from the US that was providing the networking solutions based on token ring that was very famous those days. After a couple of years in the 96, the company was growing, right? And the company was acquired by Olicom. That was a Denmark telecommunication company with the similar profile than the Crosscom. And finally, in the 1999, the Intel acquired whole Olicom. The Denmark site was closed in the 2 years, but we continued the growth, right? And things were going good, great. The focus was on the networking, on the 3G products, and wireless networks. That was very promising growth. And thing changes in the 2005 when the networking market dropped. So then we started looking for new opportunities, and our learning was to grab another technologies, to build competences across another pillars, because market changes. And looking at the universities, it's also very important to diversify competences that you are developing, that you are building on the universities. So today we've got like 3,000 of engineers, mostly engineers. We are the biggest R&D of Intel in Europe. We've got the growth, and our specialization is mostly software and firmware, but we've got some parts of the system and hardware. Personally, I'm involved in hardware. So from this slide, you can see that the strong academic presence in the city, in the country, could trigger many investments and can build a stable development of cutting-edge technologies in your area. Today we are working, we've got like 5 main segments that we are developing in D.Sc. One is a client computing, it's laptops, desktops, workstations, technologies related to the CPU, GPU. The second one is data center and AI. That's a very big group that we are developing, starting from the power management through the workload, scheduling, optimizations, networking. Network and edge, that's this group of solutions that are really is related to the network. Accelerators for the AI, big data, telco, and software and security solutions that goes through all these technologies. So that's the element what we learned after 2005 to diversify and to build many pillars. So how we started with the university. So from the beginning, it was the conducting the university to get appropriate people.
A little bit farther.
Okay, thanks. That's the competence. So we started with reaching the people who could drive the business, who could build the competence, knowledge, and who are creative. I think I'm. Oh yeah, that's the problem. Before the 2012, it was like exceptional. Our engineers were giving some lectures. They were doing their PhDs. It was not structured. We didn't have a main direct goal those time. Sometimes we founded some stipendials programs and things like that. But in 2012, we noticed that we've got the strongly growing demand on the embedded systems engineers, because we developed a lot of technologies for the storage, for the chipset, for the audio processing, DSP, things like that. And there is no, specialist on the market, especially young ones. And because we've got great electronics, right, guys from the electronics, but they don't understand the software and firmware. We've got also great software guys who don't understand the hardware. So we observed that we are struggling with the lack of the people, and we noticed that it's industry-wide problem. We talked to another companies like Synopsys, like Greenhouse, like another companies in our area, and they said yes, we see the same. We've got the same problem. We would like to do something with that. So talking to the another business representatives, we created a profile of graduate of embedded systems. So our dream employee after the studies who could be successful on the market, could work for startup, could do his own startup, go to the big company or some another way of productization, right? And so with this shape, we contacted next year the Poznan University of Technology and Gdańsk University of Technology, who is the nearest one to our R&D. We started talking with the deans, we started talking to the professors. Most of these conversations happened because of the personal contacts. So Professor Paweł Śniatała, we've got the contacts through my supervisor of my PhD thesis, so he contacted us, and we started talking, and it was the key element that happened, and it caused that the appropriate people meet and started talking about this. And we understood that universities, both Poznań and Gdańsk, is struggling with the lack of students for the electronics, because students so okay in the Java database applications the salary are so high, so it's not worth to study electronics. So it's okay, let's do something with that, and we arranged the embedded system specializations on the Master of Science level that could attract the students. Solving the industry problem, we found also relevant problem that is related to the university that we can solve in pair. And we implemented and designed and implemented the two-year course. We did, as an industry, the train-the-trainer sessions. So also universities get some extra knowledge, the lecturers get some new skill set and knowledge. We also funded the labs for the Poznan and Gdańsk University of Technology. And after a couple of years, I had some calls from higher management from Poland, and they said, Marek, we need like 5 students after embedded system from Poznan. I said, why from Poznan? We are not in Poznan. And he said, because they are the best, right? So they are really well prepared, they understand the problem, they are creative, they are very well motivated, and that's why they are asking for the Poznan University students. So from 2014 to 19, curriculums were running on the put and good, and we get like 144 graduates each year to the market. Some of them work for Intel, some for our competitors, some founded the startups. Life was really good those times because those students were really passionate about the content that we provided. We also provided some invited lectures for the students, so they were happy that they can see what is happening in the industry. We also did some mentoring for the thesis and group team projects that does the dedicated stream, and we did some modernizations through this year. So if some new technology came, some new development boards, so we tried to introduce this to the program. Talented students, again, wanted to start in the electronics, so also the university problem was addressed because the demand was like 4 times more than before our change. And we get really excellent guys, right? The managers during the interview saw that this guy is different, right? He knows what he should know. So, but life was really good, but in 2020, something changed. The AI became big. The salaries on the AI were published publicly, and students said, embedded is cool, but in AI I can get like probably 2 or 3 times more money, so we came back to the same problem. AI is more attractive, better salary, so second time the demand on the electronics drastically dropped. So the Poznan University of Technology communicated this problem. And we started talking about this very early, and that's why we succeed to recover it again. We understood what is the real reason why students don't want to study electronics. It was just AI. And because of that, we identify, okay, but there are also AI, embedded systems related technology in the edge computing that are related to the AI, right? So then we proposed the AI curriculums directly on the hardware, on the electronic stream. So we transformed the clear embedded system solutions to the edge computing. And students started picking, the good students started picking again the electronics. We did a next round of the trainer sessions about the cloud, about the backend, about post-quantum computing. We added also with Professor Mariusz Głąbowski some content on cybersecurity. So you can see that clear and transparent communication between the industry and university can bring the value for the both sides, right? And the cost is really, really low. And we are fighting for the future of the universities and future of the Polish market of engineers. Okay. This is only one story that we did. It's a particular example that is white and is commonly known. We did the same with cybersecurity, FPGA, VLSI, AI, so on and so forth. So looks like if you will start something and you will succeed, the people will really see the value. We can really scale that, and scaling this kind of programs with Eunice is really easy. And for companies like Intel, is really easy to go to the higher management and say, if we will do that, it will be scaled through like 10 universities in Europe. That is the real value, and it's a breakthrough for us, because the most precious element in the company is time of the engineers. If we can do something once and scale it, that's really a game changer. And you can see that it's ecosystem. So through the working with the education, that is, let's say, low risk project for the business, because we are not trying to rely with our deliverables from the project to the business on the university. That's the first step that builds the understanding, builds communication, builds trust, predictability, and clear communication. And it's opening thing for the research project. So starting from those time, we started working on in many areas on the research. This research is something very small, something big. Sometimes we are able to approach the EU ground. Sometimes we fail, but we are still working, and this cooperation is still growing in the scale and in the ambitions of the topics. So through my last 12 years of working with the universities, I had a lot of myths, and during the next slide, I would like to share them with you and bust them. So first myth is the universities and companies have goals that are too different to collaborate efficiently. What is our view, what we learned from the last 12 years is cooperation with the university. What are the values for business? First of all, we've gotten access to the top level researchers, the guys who are curious, who are very well educated specialists, and they've got in the blood the challenging the status quo. That's really different mindset that in the industry, and it's really needed for companies to be successful. Possibility to commissioning research work. Sometimes we want to do something, but we don't have resources, and we are ready just to pay to the university to do some research. For Intel, we are commissioning the research that is ready to publish, so we don't have any problems with publishing that. And we are happy that somebody is publishing, and because it also proves our strong position in the investment in the research and development. The thing that is very important for us is the ability to evaluate our technology in the practical, sometimes different than usual applications. You can see in the past that many technologies that we see now on the market were developed at the universities as just like checking the applications of the new technologies from the companies. We are also interested in the research papers to publish without the university. It improves our credibility and level of innovation. We are also able to obtain the research grants with the university. Sometimes it's needed because the law, and for sure it's easier to apply with the universities. Also, we are able then to influence educational program, to make them more modern and to make relevant to the current business need. And again, the scaling it with the Eunice to finding the appropriate partners is the real value. We applied this year to 2 or 3 grants. Some of them we failed. That's true. We are not always succeeding, but creating the consortium, strong consortium that competences were relevant to our ask. It was like 2 or 3 weeks. It was amazing. I was talking to the guys with the Intel with the lawyers, and they said, "No chance. You will not build the consortium in the 2 months." And I said, "Hold my beer, right?" And we did it with Paweł Śniatała in 2 weeks. So they were really surprised. Value for the university that we see as a business, maybe that's also a point to discuss how you see the guys these things. So access to the top technologies that are released or even not yet. We believe that it could be the value for you. Getting knowledge about current industry problems. What are the challenges? We believe that if we will share the industry challenges, you will be able to apply for the grants in the areas that are really important for the industry. Additional source of funding for scientific work. That's obvious, and that's the model that works in the US and in other countries. We feel like it's important to also allow to the well-skilled scientists to stay at the university, not go to the industry because it's not their best use of their superpowers. Research papers also, I believe, publishing with the industry could be interesting for you. Obtaining research grants, possibility to improve, refresh educational programs. What is interesting? We've got a lot of PhDs, like, I don't know, 60, right, in the one company, and some of them wanted to stay at the university, but they were not able because of the life conditions. And these days, they would like to teach a couple days in a month at the university, just for pleasure, just to do some research, just to do something that is not related to the business. So we also recognize this opportunity as a factor that improves our retention of the best talents, right? Because in the R&D, you can see that there is a very challenging, interesting project. The guys are really important. They are really happy that they are breaking the walls. And after that, you need to maintain it to the customer, right? And you've got 5 boring years, right? So from the business perspective, you are the guy who knows this project the best. You know the customer. You know everything. So it's optimal that you will do that. You will be bored. So giving to those people the ability, okay, you've got the boring project, but let's do the research with the university. Let's do your PhD. Let's do something. it makes them happy, and it allows us to maintain some cycle of the providing the products, maintain and improve the retention of the best people. Okay, that's the last point. So to engaging the engineers to the education. The next myth that I heard: only large companies are willing to collaborate with the universities. I heard it many times, and I don't agree. I disagree. In our opinion, both large and the small companies are interested in the cooperation, but we've got the different characteristic. So for the big companies, mostly you've got dedicated programs to cooperate with the university, and it helps. You've got also big impact through these companies, because you can reach the top level technologies, you can reach many customers, partners, so life is easy. Big companies expect the results in the long term. It doesn't need to happen like in the month or year. But what is hard? Heavy decision-making process. If you would like to do something that is aligned with the program, no problem. If you are doing something that is different, doesn't match the rules, you've got the problem, and it will take a time and it will be hard. Also, it's really hard to demonstrate the impact. For some grants that we are applying, you need to demonstrate the results and the impact in the money. So for the big companies, it's really hard. Let's imagine we are, let's say, developing the CPU, new CPU for the servers like Xeon, and it takes like 5 years, and 500 people are actively working on the design, and some features are in, some are out. We are looking for the markets. Through the 5 years, it really changes. And let's say we will do some research on the one instruction. How to prove that adding this instruction will generate the revenue in dollars? It's really hard, right? We are doing the big projects, and it's really hard to show that some additional element that comes from our research can be clearly translated the financial result. Also, sometimes successful research is not monetized in those time frame, right? It could be the completely business decision. What about the small companies? The situation is different. The light decision-making process. Probably you can reach the owners of the company, board of directors. You can talk to the key persons. The strategy is not so wide, so decision-making process is easy. Demonstrating the implementation is also easy because the portfolio probably is not so big, not so wide as for the big companies. They are expecting the results in the short term mostly. That's the difference. They don't have dedicated programs, and they've got lower impact. So looking at these both columns, you can see that it's crucial to get relevant partners for the projects. For the sum that we are applying, we are taking big companies like Intel to provide the cutting-edge technology, and small companies that are interested in application of those technology. So they will show the monetization, the productization, and we will do demonstration of the technology, and we will evaluate our technology in those specific applications. So through the Eunice, it's also easier to find appropriate partners through the companies and through the universities. You've got, guys, really great vehicle to do the amazing things, and we just need to use them. And I believe Michał will present the tools that will help us to build the connections and to build strong partnership through the business and universities. Another one, collaboration between universities and the industry is limited to the large research project. Small ones are also attractive for us. It's also good to start with the small projects to build the understanding, build the credibility, build the trust on the both sides. Even if we don't succeed sometimes, the building the trust goes through failures. small projects are more predictable. It's important for the business. Even from the business perspective, it's worth to divide the big project to the smaller ones and provide them to in the phases. Some phases, some transitions in the phases could depend on the intermediate results that we are observing. The next one, the main goal for the companies in collaboration with the universities is the low-cost development of the products. So, being completely frank, companies are not interested in developing products by scientists from the universities. And there are many, many reasons. First one, from the business perspective, university is completely out of control. Business cannot just put the work to the university if it's not controlled. That's true, right? The productization is completely different than the research. So for us, it's really hard to find the monetization and productization competences at the university. That's why it's not our goal. For productization, business needs engineers. It's a boring engineering, hard work, not fancy and exciting research for the most time. So we don't want to make you bored. We'd like to involve you to do the really interesting things that makes you happy, makes you smile, and use your superpower, not waste your time, right? That's our perspective. Next one, the goal for companies in collaborating with the universities is hire best researchers. The purpose of the business is not to capture the scientists. We understand that the university environment is completely different than the business one, and the people from the industry probably doesn't match the university, and the opposite direction it works also. Business is not a shark. We don't want to get the scientists to our company, because in the next years we'll not get the well-educated students. We will not be able to do the partnership research with the universities. So it's dead end road, right? This myth is really common, but it doesn't work this way. And even if we are getting new business opportunity to create new pillar in our development center in Gdańsk, we are asked by top level management from Intel, what universities are around? Do they have competences? What are the names of the professors? Could you share the papers that they published? So the environmental competence around the business that we are developing is also important. So we are not a sharks. We would like to support the whole ecosystem, not to consume the most precious resources that are the scientists. Sixth one, universities only need money from the companies. I'm hearing that from the companies many times. We believe that there is a whole range of possibilities to get the money in the easier way, right? Like grants, like another kinds of the funding, and what we can do is really provide the knowledge about the current problems of the industry and support the research, not only through the money to the universities. And Eunice is really, again, a vehicle that could help us to find appropriate to do that. Collaboration with companies is a result of will result in the curricula being dominated by the company topics. So we are interested in getting the students that are creative, are good engineers with the high problem-solving skill set. Technologies changes so frequently, and we don't expect from the young people that they will be competent in the technologies that we are just developing. That's not the case. We want to invest in the people, not in their knowledge on the top level technologies. So if business is interested in supporting the universities in the education, it's mostly about the general knowledge. We are talking about this with another companies like, I don't know, Nokia, Ericsson, Google, Facebook, Microsoft. They've got the same view. We don't want to dominate and do the universities private ones owned by the company. That's not the case. The things that we as an industry see, especially in Poland, and it's not related to the Poznan, it's commonly related to another university, is a lack of the soft skills through the students. So we would like to support the students as an industry with the project management, with the presentation skills, with the problem solving skills, communication, and things like that. That's what we see that we can do for the universities. We are talking with Dynatrace, we are talking with other companies, and next month probably we'll propose something to universities, how we as an industry can contribute to this area of education. And we believe that we will be able to scale that through Eunice. Maybe another university at Eunice could bring something also to our local universities. Best known practices. The summary that I prepared to understand what we see as a crucial elements to cooperate. So first of all, your current problem with the cooperation with the industry or with the university is just the starting point. If we will be able to talk, if we will be able to trust, new features will be unlocked, new projects, new areas that we cannot think even now. The approach crawl, walk, run is safe one that we are using with the Poznan, with another universities, and it really works. We're starting with the very small project, well defined, with the finite time frame, and then we are going expanding our cooperation for the new areas. Then we know what are our strong and weak elements. We are trying to be more successful through this. And build long-term relationship. It's extremely important, and I would like to express that we've got really deep and strong relation with Poznan because of relations with the people who are interested, who really wants to cooperate, who see the value. And there are some proven examples from the past, right? Like I've got the call from the Intel Labs and the chief of the Intel Labs, the research community who is working on the technologies like 10 plus years forward. And they're saying, Marek, do you have any university in Poland who would like to cooperate with us on this, and this, and this? I said, yes, I can. So I can do the blind commitment. I know that they are with us, right? And I'm calling to the dean or vice rector, and I'm saying, okay, we need 2 proposals for this and this technology. What you would like to do if you would have this technology? And I called like 5 p.m. on Monday, 9 a.m. on Tuesday. I get 2 proposals, right? So that's this kind of communication. That's this level of commitment and of trust, right? That I'm saying, yes, I have, even if I didn't talk to them, because I know that through our past experience. Communication and transparency is a key. Sometimes universities has a hard time, sometimes we have a hard time. It's really important to be transparent, to build and maintain the trust and expectations also, right? Sometimes, if, for example, from the financial perspective, we've got the hard year, we can contribute in another ways, like mentoring, like providing the lectures, so on and so forth. So we can find a way that will be convenient to our current situation. Communicate expectations. It's also important. We've got relations with some universities when we didn't when it didn't go well, right? So the expectations of the universities were completely different that we understood. And this is also a crucial element. Engage on the both sides the people who believes and who really wants to cooperate. We see that sometimes on the university sides or on the industry side, the people who don't believe and doesn't see the value tries to be engaged in the cooperation. That's really bad, and it doesn't work. Another problem with that is that after this experience, company or the university thinks that cooperation with this company or university doesn't make sense. It doesn't work. But behind there is a people who doesn't believe, right? Trust is gained over time, so it's related to the crawl, walk, and run approach. And going through difficulties is also important. There are good times, there are bad times. If you are cooperating through the 12 years, there are some successes and some failures. And what is also important is to celebrate the success. I believe this day today is one of the success. So I'm really happy to be here. I really appreciate the Eunice, and I experienced this year building the consortium for the grants. That it's a strong community that is very powerful and can change the way how we are working. Thank you very much. It was a great pleasure to me.
Thank you very much, Dr. Zmuda, for presenting such insightful and very important perspective from companies that we also cooperate with, and there is a lot for us in the future. So we are very happy, and thank you for joining our event, and thank you for the presentation. The time for questions and comment. I would like to invite you to discuss and to ask questions and of course discuss with Dr. Zmuda and others in the lunch break, or also because as you saw in the lecture, a lot of things are starting with networking and talks, so it's a very important part of starting new projects. Also, there are a lot of companies today at our universities that you can see, because there is a biomedical conference around, so you can also see the stands of the companies.
Maybe
one sentence. Yeah.
Three examples that's important for Eunice. That Marek, thank you very much, but you didn't mention what you already did for Eunice. So one was Intel, and personally Marek participated at the Imagine Innovation Cup. So thank you for that. And another important thing which we did, unfortunately we didn't success, but as he mentioned, that it took us 1 week or 2 weeks in the middle of August, which was the middle of the summer vacation. Also, Christina was involved, and we really created a strong consortium. From Catania, it was STM Microsystem, and it was about the big money, because we applied for the 5 million from the European Commission, but Intel supposed to give us 2 million Marek. Yeah? But at the end, some manager, but it was not Marek. Marek initiated it. Some manager told maybe not this time. So, and the last thing, speaking about education and teaching activities of Eunice, I think, Marek, that we can also repeat our example, what we did in PUT, that just to prepare customized programs or even courses supported by Intel. Supported by Intel means they gave us some devices and, what is still important, some money to prepare the labs, to prepare the courses. So it's really examples which worked. Thank you, Marek, once again.
Thank you very much for those comments. As you can see, the cooperation is running, and we are expecting a lot more in the future. And I would like to invite to the scene Professor Anna Kobusińska, who is the head of Division of Computing System at Poznan University of Technology, with the lecture on demystifying the power of blockchain from core concept to applications. And we also use blockchain technology in our REUNICE project, so it will be also very interesting for our participants. Thank you.
Thank you for the introduction, and actually having such a title was inspired by the product which you will have to work with or you would like to work with. And well, I would like to start with maybe separating and defining some concepts, because according to my experience, people very often mix the infrastructure with the application, mix the tokens with the cryptocurrencies. So all the concepts related to the blockchains are absolutely mixed up. So I would like to start with the very high level. So actually the blockchain is just a pure concept. It is the technology. And what we can do with that technology, we can use the technology to build the protocols which are based on the technology. So definitely you heard about many blockchains. There is just one blockchain being the technology, and we have a lot of different implementations of the blockchain. And those implementations are just the protocols. So you definitely heard about the Bitcoin protocol, the Ethereum protocol, and all the others. And then when we deploy the applications using those blockchains, we talk about the blockchain applications. And here we have a lot of examples. The first group are the cryptocurrencies applications. Then we can build the applications which are based on the smart contracts. We have the evidence use cases of the applications, and of course the centralized autonomous organizations. So different kinds of different applications have different characteristics, but this is the very high level distinctions between the blockchain protocols and the applications. So now how the infrastructure of the blockchain works. Actually, the blockchain, all the applications which are using the blockchain protocols are lawyered, and those lawyers are different, and actually there are two main lawyers which are intertwined with each other. And this is the protocol, the infrastructure lawyer, and the application lawyer. So let's start with the infrastructure lawyer first. And so the infrastructure lawyer is actually called also the blockchain. So what the blockchain is. And looking at the definition or looking at the description which was written in the Bitcoin white paper, we can see that the blockchain is the technology which provides electronic public transactions record of integrity. And I know that it sounds a bit awkward, but another definition is a bit maybe more readable. It is shared immutable ledger that securely records transactions across a network of computers. So actually, talking about the blockchain, we have the infrastructure which allows people to believe that they can read the data from that infrastructure, they can write the data to that infrastructure, and they can do it safely without being afraid that somebody else will do what he or she is not allowed to. So actually, we can think about the blockchain as of the kind of the public administration which we would like to trust to. But actually, this is not new. That were before, and we have a lot of central administrations like banks, like insurers, like Chamber of Commerce registers. They all are actually the public transactions record of integrity. So what is new with the blockchain? What is the game changer which blockchain actually brings? And the game changer of the blockchain is that actually everything can be done without that central authority which have to guard what is being done with the applications within the infrastructure. So we can do everything in a distributed way, not having to have the third party which will guarantee that everything goes correctly. And this is really the game changer the blockchain is believed to bring to the board. So actually, when we think about such an administration, we can think about the very specialized distributed database. So we can think that as the first element of the blockchain as the centralized database. What does it mean? It means that we have the data which is spread on the different nodes, but the data is spread not in such a way that A is in one node, B at the second one, and C at the third one. It doesn't work like that. Every node has to keep the full copy of the data which is shared among the nodes. So we have A, B, and C at the first node, A, B, and C at the second, A, B, and C and the third node. And the second and the third element which blockchain brings are the transparency and the cryptography. So what is the transparency? Transparency will mean that everybody will be aware what is being done on the blockchain. So what data will be saved at the blockchain nodes. And cryptography will help us to actually look for and govern the integrity of the data. So we can imagine that we have the nodes which have the copy of the data, and right now the user will come and the user says, okay, so now I would like to change C to D. So what is important, it is done in such a way that the user will not send that information just to one node, but at the end, eventually the information will be broadcasted to all the nodes. So all that information will be get by all the nodes, and all the nodes will change C into D. So actually, when every user of the blockchain application will agree, okay, we can change that value, then the transaction actually is performed and the data is changed. What can be done? When one of the nodes will think that, okay, I would like to change my value from D to E, but it would like to do it by, the node would like to do it by himself, it cannot be done, because the cryptography comes, and the cryptography will say, okay, because you are changing the data, the hash of that data is going to be changed, and then all the other nodes will see that that hash is not the same as the others. So the node will not be able to actually vote on the transactions with the other. The node will say, hey, you cannot vote with us because your history is different than ours. So probably you have the different copy of the data, and you have to wait until you will get the same data as we do. So here how the cryptography and transparency works. So what are the blockchain benefits? There are many of them, and probably the first one is the simplicity of the information and of the value chain. And here it is the third party which we can take out of the blockchain infrastructure, and we can speed up the transactions, the processing of the transactions. It can also cost less because we don't have another element which have to be engaged in the application performance. Next, we have transparency. As we already said, everybody using the blockchain infrastructure and the applications would like to know what is going on, and would like to see the results, should be aware what the other do as well. And the third and the fourth element are immutability and immortality. So it means that we cannot change the transactions. We should be able to trace what was done before and before and before. So thanks to those features, we are able to do so. And finally, we have the robustness, which means that we have the distributed system. So even if one of the nodes will go down, will be broken, then the other will work. And as long as at least one node will work, then the whole system will work as well. So coming from transparency, irreversibility, and immortality, we got something which is called perfect audit trail. It means that we are able to trace what happened in the blockchains, what we wrote to the blockchain infrastructure, what data are there, and we can be sure that nobody has tampered with that data, so the data is not changed. So what are the blockchain protocols? I told you at the beginning that we have 1,000+ blockchain protocols, and they all have the different characteristics. So the first characteristic could be the cryptocurrency. The second characteristic could be the smart contracts, which can be used for. And the third characteristics is actually the governance. So we have the different ways which allow us to govern the blockchain applications in the different way. And how, from the very high level, how can we actually divide those protocols? So we can push them into two different parts, into two different groups. The first is called permissionless and the other is called permissions. So this is what we have on the x-axis, and here we have the way how we own the blockchain, how we own the infrastructure. And looking at permissionless blockchains, these are the infrastructures where everybody can interact with and everyone can validate it. So we can imagine that we go home or we would like to start to work with the blockchain. We deploy the application, we just deploy the software, we send some value, and then everybody can use that value, and I also can see what the others' values are. I can validate the data which is sent to the blockchain. I can be the part of the protocol, just being, just saying that I would like to work with such a protocol in a permissionless way. But then people started to think, okay, maybe it is too much. Maybe it gets too much time to have such a big set of the users who work with the blockchain. So people started to think maybe it's better just to set some kinds of the permissions. So we would like to have the ability to choose who is going to work with us within the blockchain infrastructure and who is not, and which actually rights those users would have. So with the permissioned blockchains, which are public, everyone can interact with such a blockchain, but not everyone, just authorized participants can validate the blockchain. Then we come to the private permissioned blockchains. And here, this is the very strict part of the group of the blockchain protocols. Only authorized participants can interact and only authorized participants can validate. So actually, within that quarter, we have to rethink whether we really need a blockchain, because actually, what the blockchain does in that quarter, it is the same what the database can give us. And talking with the database, definitely it's much easier than talking with the blockchain. So here is a big question mark whether the blockchain is really needed. And finally, we come to the last quarter, and here only authorized participants can interact and everybody can validate. But on the other hand, how can I validate if I cannot read, I cannot write, I don't know what is in the blockchain? So actually, I would say that it is the very tricky quarter. And looking at the examples, permissionless public blockchains are the Bitcoin, the Ethereum, the Litecoin. The public permission blockchains, on the other hand, are the Sovereign or Ripple. The private permission blockchains are Hyperledger, the Serda, and here, actually, there is no protocol which could be very purely, which could purely come to that quarter. So why I'm talking so precisely about those distinctions about the blockchain protocols? Because this is the first thing which we have to consider when making the building the application, because we have to start with infrastructure. We have to project the infrastructure and then the application will come. So talking about the general characteristics of the blockchains, we can say that there are the general characteristics which are the sustainability, the interoperability, the distribution, so which in kind of the blockchain word is called the decentralization. Then we have the characteristics which are functional. So we would like to say that the blockchain, we would like to know how much we will have to pay for running the transaction on the blockchain infrastructure. We would like to know how fast the transaction will be. So how fast it will, how quickly it will stop. We would like to know whether we would like to use the smart contracts and whether we would like to govern the infrastructure in such a way. And finally, we also have, when using the protocol, the blockchain protocol to build our application with, we have to think about the user characteristics. So there could be a blockchain which seems to be very cool, very promising, but on the other hand, there are just 2 or 3 people which govern that blockchain, and the people who work with that blockchain are also not too many. There are just a few of them. And then personally, I would be very careful with such a blockchain, even if it seems to be very interesting, because there is no community working with that one, and this is not a good promise for the future cooperation. We also have to look what are the other applications which are using such protocols. It will also give us the idea whether it is maybe not important, but whether it is interesting for the others. So it can lead us somehow to choose the blockchain protocol. And now I would like to move towards the higher layer, the layer of the application. So now we are going to talk about the wallets, about the smart contracts, and about the DAOs. And let's start with the wallet, because almost every blockchain application actually uses the wallet. So what the wallet is, and in the very simple words, we could say that the wallet is actually the blockchain communication tool. It is nothing more. So to install the wallet, what we can do, what we should do, we should take the software, install that software on our telephone or on our browser, and then actually with that software we can create the account. So we will need the public-private keeper, and the holder of that private key will be in charge of that account. And this is the actions which we take just one time. And when we already have the account, we can start to work with the wallet. So what we do when we want to send some information, or we would like to send some value to that wallet, actually we send the message with the value, and then we actually ask the other person for the address of his or her wallet, and then we add that address into our wallet, and we sign it with our private key, and we send a message to the wallet, and then the nodes in the blockchain infrastructure have to vote whether the transactions can be provided or not, can be processed or not. And here is just the example of the smart contract. So actually the smart contract is just the code, the piece of the code which we deploy and then we run. So we have the functions, we have the different variables, we have the different values behind that smart contract. And every smart contract can be actually defined as the programmable account, which has some features, some characteristics. And the first characteristic is that when deploying the smart contract, we got the address. And then we can use that address to actually work with the blockchain infrastructure. So having the address, we can run the functions, we can use the rules which are defined in the smart contracts. And having that, we can also take advantage of what the blockchain promised. So take the advantage of the integrity and transparency. So we can have some data which will be used by the smart contract. And we can be sure that that data will be visible to the others, but nobody can tamper with that data. So we keep that data in the storage. And the very nice thing, very cool thing about the blockchain is also that we can use the value. So the definitions, the rules, the functions which are defined in the smart contract can also use the value, can be applied to those value. So actually we can send a message with the value, and that then that value can be changed, can go up, can go down. We can set some rules to that value. We can save it in the database. And then it means that we just process the transaction. We can send another message. So we can invoke another smart contract, and that is how it works. And actually, why I'm also talking so much about the those issues related with the smart contracts, because the smart contracts are the building blocks for the distributed the decentralized applications. So decentralized applications, or very shortly called DApps are actually the applications which are run on the blockchain infrastructure. So when you will hear the name DApp, you have to be aware that there is the blockchain infrastructure somewhere behind. There is a blockchain protocol. And how do we run the DApp? First of all, we need the front end. So we have to install at the telephone or at the browser the software which will run the DApp, and then through the transaction part, we invoke the wallet, and the wallet communicates with the backend. So with through the protocol, it communicates with the smart contracts or with the traditional databases. Actually, 9 times out of 10, these are the traditional databases. But still, because we use the blockchain infrastructure in one or the other moment, we call it as the DApp. And here we can see that the wallet actually, the front end communicates with the wallet, but the front can also communicate with the database, and then the wallet communicates with the blockchain side of the infrastructure. And when we have one smart contract, the smart contract can invoke the other, then the other can invoke more smart contracts, and in such a way we come to the distributed anonymous organizations, which have quite a huge hype right now. So what is the blockchain board view, very high level board view? We start with the chain of the blocks which are connected through the hashes. Those nodes can store the data at the databases and can use the protocol, and they can use the smart contracts. And this is all remembered at the node. So a set of the nodes together will create the blockchain infrastructure. And then finally, on the right-hand side, we have the user, which communicates through the wallet with that infrastructure, which consists of the distributed nodes, having the set of the nodes of the data of the smart contracts inside. And what are coming to the functional applications? What are the functionalized applications which we can get through the blockchain? Actually, there are 3 of them. The first one are the transactions value, the second one are the secure data storage, and the third one are the smart contracts. And from all those 3, we can have the applications which are based on the peer-to-peer transactions, so on the distributed transactions, and we can have the applications which use the evidence. And can be used in the evidence use cases. So when we would like to just divide them into kind of the quarters, as we did with permissioned and permissionless blockchains, we can say that we have at the left side, we have the cryptocurrencies. These are just the pure transactions. When we add smart contracts to the cryptocurrencies, we have the conditional payments, we have the conditional delivery. So here the smart contract says, okay, when some kind of the instruction is actually set, and when it is true, then we can have that conditional things which are invoked through the smart contracts. Then with the evidence applications, we can have using the conditional smart contracts, we have can have advanced voting, we have sovereign identity, and finally the pure evidence use cases are the trust answering. So coming to the applications, which probably will be interesting for the REUNICE members. So the blockchain applications can be also focused on the education. And there are actually a lot of such applications. Probably the most intuitive one are the first 2. So we can imagine that we have the history of the education of the student stored in the blockchain, and we have different achievement of the students, different credentials, different certificates which the students get through the course of his studies. And we can set them at the blockchain, and actually there are some universities which already have them and use them with the blockchain application, and this is MIT and this is Arizona University, which use the Ethereum to store such certificates, such student certificates. But we also can use the blockchain infrastructure for online learning, decentralized learning, and how such online platforms can be used by the teachers, by the lecturers. Well, not only to present the slides, but also to make the quizzes, to get the grades, and and to keep them at the blockchain. And this is actually the example from the Malta. And the Malta University uses IOTA, and the University at Malta uses IOTA blockchain infrastructure to provide decentralized learning through the blockchain protocols. Then we have the maybe not very intuitive application, but that could be also very useful. So the payments, the financial, the checking whether the students actually make the tuition through the blockchain, everything can be set on the blockchain infrastructure. And this is the example from Nicosia University in Cyprus. They use the WeChat, WeChain to have those transactions which are say that the student make the tuition. They can also they also have developed some payments like this scholarship payments to the students also through the blockchain infrastructure. Then another example, another application could be the case when we lessen the educational fraud. We are aware that right now everybody would like to have a lot of different certificates. And this is the case when a lot of fraudulent things are happening. And by setting certificates at the blockchain, we can actually try to lessen the fraud which can happen. And finally, at the end, the example from the Imperial College University from London, it is the supply chain management. So they have all those issues, all the good suppliers and everything, which is needed for the university to work, not really from the educational way, but also just from the administrative way to work they have put on the blockchain infrastructure. And they use just the Bitcoin. So these are the blockchain applications which already exist, but I would also to focus on the thing which is becoming more and more popular right now, and these are the micro-credentials. So what are the micro-credentials? Well, we know that the students can get the credential, the certificates, and that we can store them at the blockchain. But actually the certificate is given at the end of the course. And right now we have the focus is on the continuous education. So the students and also the lecturers, the researchers would like to make a lot of short courses and would like to govern kind of the certificates for the very small steps of the educations. And we can combine them and we can store them in the way of the micro-credentials. So the definition of the micro-credentials is the following. These are the granular awards that are distributed as digital badges at the different stages of the larger certificate. We can try to slice the certificate, the whole course, into parts and into the small parts. And actually, the most known platform right now giving those badges is the Open Badge. And I also came to the different definition or the different description of the micro-credentials, and thought that maybe I would like to share it with you because I like it quite a lot, because it was said that micro-credentials are the bite-sized chunks of the education, and that is the sentence which I like. So actually we can get the certificates for the online learning platforms like Coursera, like edX, like Udemy, and we can also use them to certificate that the students or somebody else work on that courses. So we can gather a lot of different credentials, and by getting them, we go to the higher levels of our education. And finally, at the end, just some showcases to show you that it is not just the pure research. These are the real examples. Here we have the MIT platform, which uses the blockchain infrastructure. Here we have the blockcards. The blockcards are the portfolios where the users can store their achievements for the lifetime. We have the open source university, which facilitates the direct exchange of the knowledge and the skills, and they also have the micro-credentials and the budgets. And finally, the BC diploma, this is the tool for micro-credentials, and here is the example. The different universities using that tool, but here is the example of the Queen's University in Canada. And that is all. That was maybe not so, this was more technical presentation than that one from Marek, but I hope it was kind of useful. And well, if not, I can clear some concepts during the coffee break. So thank you very much.
Thank you very much for the presentation. Yeah, I'll give the mic to the project leader, and it was very clear explanation of how the blockchain works for all of us. And there are a lot of possibilities to use it in the future in education. And thank you also for the practical examples in for higher education institutions. I'm giving the microphone to the project leader, Professor Śniatała.
Thank you. Just one comment again, because you just mentioned about several universities. Why not Eunice will be the next one which will use the blockchain for this certificates, budget, or other things. I don't, it's not for sure, but why not? And one more thing, I just want to thank you, because finally I know a little bit what is about the blockchain. I had no idea except the cryptocurrency.
Well, this is what I said. Everybody mixed cryptocurrencies with everything. That was very high level, but that was my idea behind, to give you, well, the general view of everything what is behind. And talking about the blockchain infrastructure for the Eunice University, that was the purpose of that presentation. We wanted to shine some light, but I would really deeply like to invite you for the afternoon's presentation, which will be given by my friend Adam, who actually graduated our university. We were a bit competing with each other because we were at the same year, and well, one year Adam was better, the other year I was better, but then Adam went to USA to make the Ph.D. at the Purdue University, and right now he's working for the company which is building the blockchain infrastructure, and it is called SUI blockchain, and Adam and his manager, who is from Greece, so they both have the European roots. They will describe how the infrastructure can be used for the REUNICE. And the Kostas is the manager of Adam, has a very big experience with European, different problems and European also issues related to the blockchain. So I would like to invite you right now to the afternoon's talk.
He is already in the Eunice family, because we have University of Peloponnese in Eunice, so Greece is our as well. There's a question.
Thank you, thank you very much. And now I'd like to invite to the scene Michał Weissenberg from the Faculty of Computing and Telecommunications at Poznan University of Technology. Michał is currently the REUNICE project officer and the faculty coordinator for projects. And Michał will give us the insights on the summary of the results of the REUNICE project, among others, one of the platform that was created on the blockchain technology. So Michał, I'm giving you the floor. Thank you.
Thank you so much. Where is a pointer? Maybe, oh, here. Okay, thank you. Good morning. It's a great pleasure for me to be here and give this speech about the summary of the results of REUNICE project. I will do my best to say what we done. First of all, I would like to thank you all, our Commitment University, all our partners, without use some of our tools, I hope so in the future. So we are cooperate strictly also with our new members, Karlstad University, University of Peloponnese, and Polytechnic Institution of Visio. And of course, REUNICE start doing a project, and what's about our results, what we done in the last 3 years. So we create 3 different digital platform to support cooperation between university and our university, our Eunice University, with other alliances and also with the company and industry. So we have 3 different platforms. EEP, Expertise Exchange Platform, supported by Catalyst. This platform is all defined, is working currently, is available, is after the piloting phase, and we can use it. We have also the Open Science platform based on the blockchain technology, and this platform is currently in a pilot phase and attempt to convince scientists to use the platform, and this platform is used by many researchers, and now we are working on to develop some new tools and so on. And also we have AI platform, a platform for exchanging competencies related to artificial intelligence, and this platform is also running, and in some cases we need to contribution from the partners is needed because we are trying to find as many researchers that are share their knowledge and experience and everything what they done in our AI area. So what about the platform? Because we know that we have 3 platforms, but for what we can use this platform? So the first one, EEP powered by Catalyst platform, is the platform for creating a campaign for a project, solution, problems to be solved, and information about open calls. So we can share idea for some solution, some proposal, some suggestions. So if you have any problem, you can put this problem to our platform and we can try to find the idea how to help you. So you can say, we want to cooperate with one of the universities in some area, and our researcher may share with you some their ideas to solve this problem on how to help you. So this is the strained cooperation from internal and external actors. So this is for the cooperation inside the Eunice, but also with other sectors, with industry and other universities. And we establish a cooperation and coordinate it within the idea to start creating, for example, proposal for a new project and so on. So this is the first platform. Second platform is an open science platform based on the AI and blockchain. And this platform is to create an account of all researchers working in the Eunice to put in the one database all information about their publication. And then information about from open science and connecting people to each other, connecting people who are working on the similar area by using AI. So the AI model, LLM model, try to, an NLP model, analyze the text of the article and try to find the similarities between many different researchers and try to find the cooperation with them and create a group for them where they can discuss the ideas to each other and can discuss what they do together. So this is a platform to connect people working on the same area using AI, automatically creating connection between different people from different universities, because we have 10 universities, we have many researchers, and for sure we don't know everyone. So if we have one place where we have all the articles, all the publications from our researchers, and then artificial intelligence can read all of them and try to find the connection, find the similarities in the area, it will be easier for us to start cooperating in the future. And the last platform is an AI platform where our researcher can post their own achievements or own software and hardware that they have and information about their knowledge, project that was done, and so on. And people who are working in the AI area may starting connecting to each other based not only on the publication like Open Science platform, but mostly about the project, most information about the resources that we have, we can share with each other, for example, servers and so on. So this is the last platform. These 3 platforms will be added value for our Eunice umbrella of platforms, and in the future probably we'll use all of these platforms in our ecosystem to try to encourage as many as possible researchers to working together and try to create a new connection between our university with industry and other companies, other universities. But we don't work only on the digitalization tool, because it's not the case to create some tools. We need to take care also about our people. So we try to promoting excellence in research and innovation, fostering diversity, inclusiveness, and gender equality across our alliance. So we take many activities like a career paths catalog and database of position and partners for knowledge exchange. We training and education program. We create training and education program for research, support staff and coaching and mentoring models for young researchers. and creating a project including an inclusive communication charter for the Alliance. So, based on the many different European Commission documents like ERA policy, like some finance but EU project like CARDEA project, and many activities inside the Eunice, many discussion between partners and so on, we create the paths catalog and database of position at partners for knowledge exchange and the careers path. So how to our young researcher, our co-workers and so on can develop their career in the Eunice area and also in the other area, for example, in the industry. And what about the knowledge to share, how to share the knowledge, and where we should go with our knowledge to help other universities, or what we can get from other university when our career may go smoother and faster to our goal. And in our diversity and interconnected world, also inclusiveness is very important part. We want to create the secure inclusiveness area for all our students and our workers. That's why we create inclusive communication charter also. And in this inclusive communication charter, we include some guidelines focusing on language and terminology, clarity and simplicity, inclusive design, digital accessibility and inclusivity, physical inclusivity, representation, respect and sensitivity, feedback and accessibility support. So we try to find the way to build as much as possible inclusive European university with open for all people, where we can work together, where we can take care about our students and do as much as possible that everyone will feel pleasure here, not only at PUT of course, but here I mean in Eunice. And we try to, oh, thank you so much. Okay, so I will try. So what about next element? We try to increase the visibility of our young researcher and try to help them with their work. So we also organize a mentoring program for young researcher for the Maria Skłodowska-Curie Action postdoctoral fellowship. This program was the mentoring program for young researcher, where they can get a knowledge how to create the proposal for the postdoctoral fellowship for Horizon Europe second pillar call from European Commission. We organize a mentoring program, some seminars and so on. After that, young researchers for all our universities prepare their own proposal, suggestion, ideas, share with us. Then we have some competition for them, and the best idea was chosen. And after that, we offered external company support to prepare a full proposal. This proposal was sent to European Commission, and we hope so that one of our young researchers will get the grant for a postdoctoral fellowship. What next? We try also promoting sustainability science for business and society in line with current and future challenges of European universities. So we have another activities for trainership activities for students and PhD students and master students. We organize workshops, tutorials, summer schools, and create a competences center where we can share our competences with each other. So we organize, for example, 3 editions of the conference Goes Day in Poznan University of Technology, especially in the area of AI, where we have many speakers from industry, for example, from Intel also, but in DeepMind, Google, Meta, Microsoft, NVIDIA, IBM, and many other very huge company, especially in IT area. And this Goes Day was in hand our very commitment and very nice students who create this conference and working on it. We have also the REUNICE workshop, Multifunctional Materials and Sustainability in Catania, where a researcher in the multifunctional materials and sustainability area may share their experience, they work together, finding the opportunity to discuss their idea, find the cooperation possibilities, and so on. So there was a very nice and very useful workshop. We had also 2 doctoral summer school, also in Catania. It's a very nice place, maybe that's why. And the weather is also every time good, so maybe not in summer, but okay. So first, REUNICE doctoral summer school was about the sustainability science, and the second one was a doctoral summer school on multifunctional materials and sustainability. So we had many young researchers from doctoral school, from all our partners university, who came to one place and worked together. We had the speakers from few REUNICE members also, so that was a very nice idea. And we had also the certificate program in sustainability management with 3 weeks online and 1 week on-site, also in Catania. The basic concept of sustainability in different dimensions, social, environmental, and economic, and concept leading to the implementation of sustainability in public organizations, private companies, what taking into account. There was the cooperation with some industry and university, because, like today Marek said, we don't need to take care only about the engineering knowledge, but also about some different part of the knowledge of the students, some maybe not technical one, but also how to increase the knowledge in the sustainability management. And we had also the Eunice International Internship and Research Stays portal. The portal fosters international traineeship and research networking by research stays and thesis offers targeted to students of all disciplines and all levels of education. So we create the place where students can find the possibility of international thesis and internship for them to go to another country to do the internship. And we have also the dissemination and communication. For example, today, so we are working on it. We create the communication strategy. We try to take care about the diversity, inclusiveness, and gender equality in our alliance, in our idea, and monitoring long-term dissemination and communication strategy. So we have our very well work social media and our website with many information about us. So if anyone of you don't know something, you can go to our website, and you can see we have many people who create a content. And we prepare also the Invisible Unveiled exhibition, where we try to show different side of the science. The researcher from Eunice universities create a picture, very nice picture, where they do their research, and probably in the break you can see this photo somewhere here. So there was many amazing photo also. And this is the end of my presentation. I thought that I will have less time, so maybe I will not say it once again, but if you have any questions, we have plenty of time for them, and we can start discuss some issue. And thank you to, of course, European Commission, because all of this project is supported by funding received from European Commission under Horizon 2020 Research and Innovation Program. Thank you.
Thank you very much, Michał, for the presentation. what are the next steps? So we'll be meeting with our partners from all the 10 European universities for a REUNICE project management team meeting in a moment, well, after the lunch, and we'll be discussing like what is still to be done in REUNICE project, but what will be the future. It's also important. That's why the following meeting will be on Eunice for You project, when we'll be discussing the possibilities of continuing some of our of activities and platforms in the future, and also to make the platform sustainable and to like keep them working in the future also. So that will be our next meeting. And in the afternoon, we are inviting you for the lectures, which was already announced, but I would like to announce it one more time. It will be at 5 p.m. and it will be a lecture on systems and cryptography innovations in the SUI blockchain. It will be given by Kostas Chalkias, the co-founder of Myson Labs, the chief cryptographer, and Adam Welt, the staff engineer, also at Myson Labs. And for people watching us on the stream, we would like to ask you to register via the website, because it will be provided on Zoom platform, and our participants are invited to join us in the room 206 at the building A3, Faculty of Electrical Engineering. Will guide you. And as Michał said, in the during the lunch also we can see the pictures from our exhibition, the art exhibition, but there's also the science exhibition. So those are pictures showing the science, but shown in an artistic way. So it's a possibility to get familiar with that. And also, as I mentioned, there are a lot of stands of companies because of the biomedical engineering conference. And also it's a great opportunity to network. So I invite you to discuss, to start new project, and or to get to know each other better. And thank you very much for coming. We will now close the streaming, and I invite all of you to take the family picture, and the photographer is already with us. So we will move to a place where it can be taken. Thank you very much once again.